think we're going to build the second battery, and that will go in here like this. And for that I can show you a really cool new small device which I will do a separate video about, which is a spot welder. I made a video in which I tried to build a spot welder, but I haven't published it yet. And the reason I haven't published it is the reason I haven't published videos in a while, which I should have mentioned in the beginning of this video. Alright, now I have this piece of cardboard on the side of the cell and with a bit of overhang over here, because this is where we spot weld to the positive, and I'll just get this in like this so that the tab or the nickel strip goes over here and doesn't short, and just a piece of Kapton tape or a bit of Kapton tape on both ends to well, essentially protect any shorts. And then this one goes over here, and again a bit of Kapton tape, and we can actually do the spot welding. Alright, and here we have the battery pack, the janky battery pack in the least jankiest way. Kapton tape to hold both cells together, the cardboard in between, and just so you understand why we have this cardboard, this is where we connect the cells in series. So normally the cell's body is negative and this is negative. This is negative for the right cell, this is negative of the left cell. When we connect them in series and we would short both bodies, this right cell would have its positive connected to negative. Bad thing. And therefore we use cardboard to have more physical separation, and the Kapton tape to hold it together. Nice thing about Kapton tape, it's really heat resistant. And now, slight introduction to our spot welder. Yeah, that's it. This is the spot welder. Looks quite interesting. Is interesting. It's battery powered, USB charged, has lithium packs inside, and yeah, it actually works for like spot welding. So a video about this thing will follow. Hello! But now we simply use it to make the spot welds. So these will do just fine. Get them inside. So this is our series connection. Get this one over here and fire in the hole. And another one for good measure. So this is stacked down. Now we go over here, and I have to shorten this first. This in place. And hopefully that's a good bond. I don't know, it doesn't look too good. Let me just go up in power and do one more for good measure. Yep, that's fine. Okay, so this goes to your negative. Hold it in place. Get the other one. And 3. That's fine. I'm going to do it like this, so that I have an easier access, because yeah, that's better. So I'm going to solder it, or rather spot weld it in place like this. And I'll simply get a piece of cardboard underneath, because that's the positive, that's negative, we don't want them too short. I'm going to do the same with the other tabs so that I have easier access from the top instead from the side. Where's the leftover piece? Oh, there we go. Okay, so this one can short because this is negative, this is negative. Now this battery pack is not done. I have to do something else. I have to get cardboard over here and cardboard over here, and then I can insert it. So we are done with this part. I can get this away and bye-bye. Alright, and now the secondary battery pack is done, and this is somewhat like how you do these things, except I highly recommend you use the battery holders. But if you have like very tight space like I have here, this is what you can do: cardboard and Kapton tape. And now this fits nicely in here, and we have both sides isolated and the two tabs on top, which is nice and easy access. And I'm so dumb, I need access to this as well. Oh no. Okay, so let's just pretend nothing happened, and this is how it looked the first time around. I mean, I didn't do any mistake, no. And I'm not even going to mention what I just did, which was really dumb. I spot welded this tab in place, had the long piece still attached, and I thought, well, let me just bend it to see how far I'm going to, well, where I cut it and how far it has to go out, and I shorted the battery, and here you can see this slight small dot. Yeah, not really good, but nothing bad happened. It was just a brief moment. Be careful. Normally I cut them beforehand before I actually spot weld them, so that something like this can't happen, but yeah, sometimes it happens. Now the battery fits in nicely, and this one again will be attached with some foam tape. I think next order of business is the installation of the BMS. Okay, plans changed slightly. Yesterday it was pretty late and I stopped filming. And when looking at the footage and also the audio, I noticed that the video is already pretty long, so I did a bit of stuff off camera, nothing too fancy. The BMS has still to be installed, which is what we're doing after I explain what I did so far. And I noticed that I had some issues with the audio. I will keep recording how I did so far into the video. Maybe I have to do a bit more in post, and I'm not going to, if it turns out bad, I'm not going to record audio how I do right now, because this kind of an experiment, and I tried to make the audio better, but it actually doesn't sound too good. But we will stick to this right now. So I did a whole lot of things off camera, nothing too fancy, so let's go over this quickly. So number one, I installed the battery indicator over here. I was able to verify that there is enough space between the batteries and the backside of this thing when installed. I got this thing in place, got a 2-pin connector with the positive being interrupted by this tactile pin over here. So if we want to see the battery capacitance, let me just quickly connect this. So we have this connected. I press this button and we see all the lights going on, lighting. So the lights going on. Right now it's at 8.2 volts, so this is almost full, and that's like 75%, 50%, something like that. And if only the red outer thing is illuminated, it shows you that the battery is below 25%. I simply connected the 2-pin connector to positive and negative. Nothing too fancy. I mean, I don't have to show you how I installed this. Again, this is a special case, so the way you do it might differ. I simply got 2 standoffs for the module. I soldered the tactile switch on a small piece of perf board, also 2 standoffs, and then I can simply press it from the outside, and a few zip ties to hold the cable properly in place, as well as a lot of Kapton tape to prevent any potential shorts. I also got a bit of Kapton tape on this USB connector over here, because we could have something shorting. That's just a bit of, if we're working in such tight spaces, you have to make sure that nothing can happen. I also installed the 2-pin connector for the USB port extensions, so the additional 2 USB ports, which you don't have to do if you well, if you don't try to have the USB ports at 2 places at the same time. This small 2-pin connector over here This is the one that goes for the USB ones, and it's simply soldered in place to the USB port positive and negative, and again some Kapton tape and this piece of foam to hold it in place. Oh, speaking of pieces of foam, as I said before, I installed some pieces on all the four sides of the main battery, as well as a longer piece over here. So when the top part is in place, it slightly presses down this battery as well as these two batteries, so that will also prevent any the foam tape, the double-sided foam tape, to come loose over time due to vibration. And beside that, I also got the 2-pin connector installed to the buck converter over here, as well as the small one to the DC input jack over here. This is pretty much everything that I did off camera. The main cabling, the most important cabling, as well as the installation of a few heatsinks, which I do recommend. Heatsink will go on this small IC over here for the USB thing, USB, the buck converter that produces 5V for the USB ports, as well as a small heatsink for this chip over here for the buck converter, as well as a heatsink for the two MOSFETs on the BMS, because you have to keep in mind the BMS is designed for 8 amp, and if I want to, well, essentially extend its capabilities in the future, I might need all of the 8 amps available. When it comes to cabling, I'm going to use two sizes of cables. I'm going to use 18 AWG silicone wire, so for the main connections that handle high current. I think 18 AWG is rated for 11 amp maximum, so 8 amp is totally fine. Well, it actually depends on the classification of installation, but yeah, I think the lowest rating is 11 amp. And then I'm going to use for the center tab of the battery for balanced charging, as well as the connection to the USB port, and everything that handles almost no current, the 20 AWG silicone wire.